discuss computations combinations concept session. What is fundamental principle or counting principle? If an event occurs in m different ways, following which another event occurs in n different ways, then the total number of different ways of simultaneous occurrence of both events, that is, occurrence of one event after the occurrence of the other event. The total number of ways in which both the events can occur one after another is m into n. This can be extended to any number of events. So if one event occurs in m ways, after that, if another event occurs in n ways, then the total number of ways in which both the events occur simultaneously in a definite order is m into n. And the number of ways in which exactly one of the events will occur is m plus n. This is known as addition principle. Either of the events means m plus n. Both the events one after another means m into n. This is known as fundamental principle or counting principle. For example, if one work can be done in three ways, and after completing this, if another work is done in two ways, then the number of ways in which both the works can be done one after another is 3 into 2, 6 ways. That is the meaning of fundamental principle or counting principle. Then the number of ways in which either of the events occurs means 3 plus 2, 5. So what is factorial notation? N factorial means 1 into 2 into 3 into the product of first n natural numbers. Or same thing can be written in reverse way, n into n minus 1 into n minus 2 into so on up to 3 to 1. This is known as n factorial, which can also be written like this also. This is also another notation for factorial. So what is the meaning of 5 factorial then? 1 into 2 into 3 into 4 into up to 5, or starting from 5 right up to 1. 5, 4, 3 to 1 by decreasing 1 each time. 0 factorial is defined as 1, and 1 factorial of course is 1. Now same 5 factorial can be written like this. This is nothing but 5 into this term this thing can be written as 4 factorial. So 5 factorial can be written as 5 into 4 factorial. 10 factorial can be written as 10 into 9 factorial, or you can also write it as 10 into 9 into 8 factorial also. So in general, what is n factorial means? N into, reduce this by 1 and write factorial for that. N minus 1 factorial. Next, what is 2n factorial? 2n factorial can be written like this: 2 power n into n factorial into 1 into 3 into 5 up to 2n minus 1. Remember, factorial is not defined for negative integers. That is, minus 2 factorial, minus 3 factorial, so on are not defined. Next, what is NPR? NPR denotes the number of permutations of n different things by taking only r at a time. Out of n, you have to consider, you have to take only r and you have to arrange them. Then how many arrangements you get means NPR. So remember, permutation means arrangement. So what does NPR denotes? The number of permutations of n different things by taking r at a time. And NPR is defined as n factorial by n minus r factorial. Next, the number of permutations of n things taken all at a time. Instead of taking r, you have to take all at a time. When p of them are similar of one type, q of them are similar of second type, r of them are similar of third type, and the remaining are all different, is n factorial by p factorial, r factorial, q factorial. For example, suppose if there are 3 A's and 2 B's and 2 C's, how many things are there? 3, 5, 7. In how many ways you can arrange them means 7 factorial by, this is repeated 3 times, so divide with 3 factorial. B is repeated 2 times, 2 factorial. C is repeated 2 times, 2 factorial. So the number of permutations of the things by taking all at a time, when p of them are similar of one type, q of them are similar of second type, and r of them are similar of third type, is n factorial by P factorial, Q factorial, R factorial. Next, number of permutations of n different objects taken R at a time when a particular object is always to be included. Is R factorial into n minus 1 CR minus 1. It is not important. Next, permutations and repetitions. The number of permutations of n different objects taken R at a time when repetition is allowed any number of times. That NPR means repetition is not allowed. N power R means repetition is allowed. So how many permutations are possible of n different objects taken R at a time when repetition is allowed any number of n means n into n into n into R times, so which is n power R. It's circular permutation. Circular permutation means here objects are arranged around a circle. So what is the formula for number of circular permutations of n different things taken all at a time? N minus 1 factorial. In this circular permutation, we have clockwise as well as anti-clockwise arrangements. If those clockwise and anti-clockwise put together is n minus 1 factorial. Suppose in any particular case, if clockwise and anti-clockwise arrangements are considered as identical, then you should take half of it, n minus 1 factorial by 2. Next, the number of circular permutations of n different things taking R at a time, distinguishing clockwise and anti-clockwise. That is, their anti-clockwise and clockwise arrangements are taken different. Then NPR by R is the number of circular permutations. Out of n, you take only R. Next, combination means selection. What does NCR denotes? NCR denotes the number of combinations of n different things taken R at a time. And that NCR is given by n factorial by R factorial into n minus R factorial. And we know that this part is NPR by R. So NCR is nothing but NPR by R factorial. NCR is also denoted by C of n comma or like this or like this also. It's the number of combinations of n different things taken R at a time when P particular things are always to be included, n minus P CR minus P. When P particular things are always excluded, n minus P CR. When P at least one means selection of 0 will not be there. That is, it starts with NC1, NC2, NC3, so on, NCN, which is 2 power n minus 1. This can also be called as total number of combinations of n distinct things by taking one or more. Next, the total number of ways in which it is possible to make a selection by taking some or all out of P plus Q plus R things when P are alike of one kind, Q are alike of second kind, R are alike of third kind, and so on. Is given by P plus 1 into Q plus 1 into R plus 1 minus 1. Next, the total number of ways of selecting one or more things from P identical things of one kind, Q identical things of second kind, R identical things of third kind, and n different things is P plus 1 into Q plus 1 into R plus 1 into 2 power n minus 1. Here also, the total number of ways in which it is possible to make a selection by taking one or more. Next, number of divisors. Suppose if a positive integer n is given, to find the number of divisors, the procedure is like this. First, express the given positive integer in powers of prime numbers like this: P power A, Q power B, R power C. Here P, Q, R are prime numbers, distinct prime numbers. A, B, C are natural numbers. And the total number of divisors of n, including one and the given number, is A plus 1 into B plus 1 into C plus 1 into so on. And the formula for sum of divisors: P power 0 plus P power 1 plus P power 2 so on up to P power A, Q power 0 plus Q power 1 plus Q power 2 plus so on Q power B into R power 0, R power 1 so on up to R power C. That is the formula for sum of divisors, and this is the formula for number of divisors. Next, the number of ways in which the given natural number n can be resolved as product of two factors is half into a plus 1 into b plus 1 into c plus 1 so on. If the given number is not a perfect square, half into a plus 1 into b plus 1 into c plus 1 so on plus 1 if n is a perfect square. Next, division and distribution. The number of ways in which m plus n different things can be divided into two groups containing m and n things respectively. For example, if there are 10 things and you have to divide that into two groups consisting of 4 and 6, then it is nothing but 10 factorial by 4 factorial 6 factorial. Like this, when you have m plus n things, and if you want to divide that into two groups consisting of m and n, the total number of ways of division is m plus n factorial by m factorial n. If m is equal to n, it means the two groups that are to be divided should be equal. Then the number of subdivisions are, put m is equal to n, then 2n factorial by n factorial, 2 factorial. So remember, you should divide with 2 factorial whenever the number of things in both the groups are same. For example, 2n should be divided into two groups consisting of n and n. When this number is same, then divide with 2 factorial. After division, if you want to distribute these to two persons equally, then 2n factorial by n factorial into 2 factorial should be, so that the 2 factorial gets cancelled. Same thing, if we have m plus n plus 5 things, if you want to divide into three groups consisting of m and p, then the number of ways are m plus n plus 3 factorial by n factorial p. If again three n things are to be divided into three equal groups consisting of n and n and n, then it is 3n factorial by n factorial, 3 factorial. And if you want to distribute to three persons equally, then it should multiply with 3 factorial so that 3 factorial gets cancelled. Next, p ranges. The number of ways in which n letters can be placed in n envelopes so that no letter goes into the envelope meant for it is n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial so on up to minus 1 whole power n. This is a formula for number of p ranges.